Hi guys, today we're covering direct variation. Direct variation is a specific relationship in which there is a constant ratio of y over x between two variables. This constant of variation is a variable, the letter k. When we think about it, we can also think about it as it's representing the same thing as m in slope-intercept form. And remember that m is the slope. The k is specific to direct variation. It is the constant of variation. K, c. So constant is the k variable. The direct variation equation are written in the form of y equals kx. Notice this is similar to y equals mx plus b, but notice there is no plus or minus at the end of it. Okay, so now identify the constant of the ordered pairs below. So the first thing we're doing is looking for the constant. Then write a direct variation equation, that is step 2, to represent the relationship. Remember that when we're looking for the constant, which is k, that is the ratio y over x. So I take each one of these, and we want to make sure that it's the same. So I'm going to take each one, and I'm going to put 4 over 1, 8 over 2. Each one of these so far is simplifying to 4. 12 over 3, 4. 16 over 4, 4. They are all the same. So therefore, my k is equal to 4. So my equation, so this is step 1. Step 2 is the equation. Remember that equation is in the form of y equals kx. The only thing that we are adjusting is the k. The y and the x stay. So we have y equals 4x as our equation. That's from a set of ordered pairs. Next, let's look at it when it's set up as a table. So again, we are setting up y over x. So in a sense, we're taking the -8 and we put it on top of the -12, which simplifies to 2/3 because you're dividing by 4. So to confirm, I'm going to do, -4 over -6. That is 2/3. This right here says it's going through 0, 0. That is a special situation. That confirms I'm dealing with direct variation, because if it goes through the origin, it is direct variation. And then we have our last one, which is 2 over 3. These are all the same. So therefore, the k is 2/3. So my equation is y equals 2/3 x. Both of those are my answers. And these are the same ratio. If you simplify and they're not the same, then it is not a direct variation. Okay, moving on. Now we're going to look at different forms of equations. Okay, if it is a direct variation equation, which you will see me abbreviate as DV, then it must be in the form of y equals kx. If it's a yes, then you need to tell me what the constant of variation is. That is, what does k equal? So let's look at number 6. This looks like the form of y equals kx. There's nothing added or subtracted to it. It's not something over here. I don't have to simplify anymore because y is by itself. So you want to make sure that you simplify or solve for y. This is already solved for y. So what is in the k spot? Negative 4/5. So this is yes. And the k equals negative 4/5. There we go. Number 7. Well, when I look at it, first off, I notice there's no x in here. There is no x variable. Well, notice in the original form, it has a y and an x. So right off the bat, I notice something's off. So since there is no x value, no x, so the answer is no. It is not a direct variation. Not a direct variation. A couple of more from here. 12. There's a little bit more for this. It's not y equals by itself, so I first have to solve for y. So I'm going to subtract 4x from both sides, and we get 2y equals negative 4x plus 6. Y is not by itself yet, so I divide by 2 to everything, and I get y equals negative 2x plus 3. Now, this is where it's throwing us a curveball. It looks like the y equals kx form, except it has this plus 3 on here. That's addition. Notice it has no additional subtraction on here. So because of the plus 3, this is a no for direct variation. And that is because of the plus 3. Okay. Finish the class notes. Make sure you follow your pacing guide.